To round things out, we need to look into vitamins and water, because we've already dealt with the four main macromolecules, but vitamins and water are also an essential aspect of the digestive process. So we'll start by looking in the small intestines. In the small intestines, you're going to have your fat-soluble vitamins. Vitamin A, D, E, and K are all being absorbed here. But what's interesting, because they're fat-soluble, think about back to the last video. We just talked about lipid digestion. We had to use micelles as far as the transport. Same thing happens here. These fat-soluble vitamins need to utilize micelles for transport, and then basically they're being put into the cells that need them. So diffusing into the absorptive cells. But the other vitamins are water-soluble, things like vitamin C and the B-complex vitamins. Now those being water-soluble, they can be absorbed either by diffusion, active transport, or passive transport. Now you're saying, well, hold on, there's only 2 letters. Yes, but the B-complex has a whole series of vitamins. So it depends on where in our system, which vitamin you're talking about. That's where there's different ways they can work here. But what's interesting is vitamin B12. We mentioned this previously back with the stomach, because back in the stomach we mentioned the intrinsic factor. Intrinsic factor is necessary because vitamin B12 binds the intrinsic factor, and this is absorbed through endocytosis. One of the things it helps with is your red blood cell production, but there's many more things than that work in your system. So again, from lipid-soluble and then water-soluble in the small intestines. Large intestines. We know the large intestines have a bacterial flora that lives there and is perfectly fine. They produce vitamin K and the B-complex vitamins. That means your large intestines can absorb them at that point. So large intestines is also helping with absorption of vitamins, vitamin K and the B-complex. All right, jump over to water. Water, about 85 to 90% of water in your body is absorbed through your small intestines. Now think, well, hold on, the large intestines absorb water. True, it does, it helps out. But majority is coming in and back into your system via these small intestines. So again, that's really the main organ that's absorbing and pulling things in. Now the key thing here is higher concentration in chyme. That means the chyme that's sent into the small intestines has more water than the cells around it. That creates an imbalance. So the water wants to move into the cells. We're looking at net osmosis because we also have movement of ions. It's not just water. So we're looking at how this is working, how these gradients are set to move those components from the intestines into the cells. So water movement, there's a whole lot of it all heading into the small intestines. Now, this diagram is meant to kind of show where the water is entering the system and then where it's being pulled back out. Any given day, you're inputting about 2,000 milliliters or 2 liters of fluid. Saying, I don't drink that much water. You don't have to drink that much water because the food you're eating also has fluids. If you're eating any fruits or vegetables, they have fluid in them. So pretty much anything you're ingesting, maybe with the exception of crackers, they're kind of dry, but most of the food you're ingesting is going to have water in it. So between what you're drinking and what you're eating, it should hopefully balance out to about 2,000 milliliters or 2 liters. Now, depending on your activity levels, you might need to drink more to replace lost fluid from sweat. But that's again if you're sweating a lot and really working out a lot. Now that fluid comes in. You then add saliva. About 1,500 milliliters of fluid is added into the already 2,000 you're absorbing. Then take that, add another 1,500 in gastric secretions, another 1,000 roughly milliliters from bile, looking at another 1,000 milliliters from pancreatic secretions, and about 2,000 from intestinal secretions. You've really jumped up now all of a sudden. We're give or take around 9,000 milliliters of fluid at this point in the small intestines. Well, you're reabsorbing, look at that, roughly 7,800 milliliters of that 9,000. So then you send that down into the large intestines. You add another 200 milliliters, give or take, which means you end up with about 1,400 milliliters of fluid in the large intestines. You don't want to release that much out of the large intestines. So you end up absorbing about 1,200, 1,250 or so. You only lose about 150 milliliters of fluid on a daily basis, on average, out of your feces. Now, sure, the consistency of feces can change. That means the amount of fluid leaving can change. But that's also, if you think about why cases of diarrhea can be so problematic, you're losing a lot more water than that 150 milliliters, which means your body can dehydrate very quickly if you're having massive amounts of water leaving the small intestines to the large intestines and out of the body and not being reabsorbed. So it's important to make sure the small intestines can reabsorb that fluid and keep it back in your system to maintain hydration. So a lot of fluids moving around, a lot of water moving around. Your body needs a lot of water to survive, a lot of water to function, and a lot of water to balance off. So vitamins and water absorption, two very important aspects to balance out from your digestive processes and balance out homeostasis in your body.